In this lesson, we talk about scatter plots and trend lines. And this particular lesson focuses on the heights and weights of famous NBA stars, Kareem Abdul-Jabbar, Larry Bird, Wilt Chamberlain, Patrick Ewing, Magic Johnson, Michael Jordan, Scottie Pippen, and Isaiah Thomas. And they've plotted the height in inches and weight in pounds over here on this scatter plot. And our goal today is to create a trend line that best represents our data. That way we can make predictions about other heights and weights of NBA players. So it says here that students drew lines to fit the data. So student 1 connected points for Isaiah Thomas, who was our shortest player, to Kareem Abdul-Jabbar, who was our tallest player. Whereas student 2 connected Isaiah Thomas as the lightest player to Wilt Chamberlain, who was the heaviest player. So basically, student 1 looked at heights, and student 2 looked at weight to figure out what points to draw their line between. Neither of these are actually great representations, okay? And the reason why is if you look here, we have 1, 2, 3, 4 points above this trend line, and we only have 1 point below. And so it's not representing all of our data equally, right? So that one's kind of skewed too low. Whereas if you come over to the right, when we focused on weight, we had 1, 2, 3, 4, 5 points below, and none of them above. So that also did not evenly represent our data. And this is a common misconception with students where they think that a trend line has to go through like a start and end point, and that is not the case. So it says explain why neither of these lines fits the data well. So the trend line should evenly split the data. And sometimes it'll go straight through a point, and that's fine. But the ones that it doesn't go straight through, we need to make sure are spaced evenly above and below. Now, that being said, we're going to also add in that the trend line may pass through, oops, not a comma, don't want it there, pass through all points, no points, or some points. Again, the misconception a lot of my students have is that it has to go through any at all, and it really doesn't. If our points were just spaced all out here and the best trend was just to go in between them, then that's what we would do. Or if it happens to hit some along the way, so be it. But you do not have to like start and end on 2 of your data points. That's not a rule. Okay, so turning the page, we have 2 more students to look at. And student 3 happens every year. Okay, we get so fixated on, well, Miss Wright said that we needed to have them evenly on each side. So there's 4 here, and there's 4 here. So that means this is a trend line of my data. Now, we can get so fixated on the rules that we forget the point of this trend line, which is to follow the trend, right? Our data points aren't doing this particular trend. It's definitely not that steep. It definitely should start way more over here and end way more over there. So like, don't get so fixated on the rules that you forget what you're actually doing here. So anytime you see trend lines that are just crazy looking and don't really look like what the data is doing, go ahead and mark those answer choices out. They're only there because it's a common misconception for students to fixate on it being split evenly, and we forget the whole reason is to actually model the data. So for student 3, he's not our winner. That's not the one we want. Student 4 makes us happy, okay? So the reason student 4 is the best choice, if we look above, we have 1, 2, 3, 4. If we look below, we have 1, 2, 3. Oh my gosh, it's not perfectly even, and that's fine. The general evenness is there. Being 1 apart is fine. It doesn't have to be exact because it did pass through a point here, so he's not on either side. So we're going to have an odd number. It happens. The point is, it's following the overall trend, and it does a nice job of splitting the data in half, above and below. So it says, which line is a better fit for the data? Explain. And we're going to say student 4 had the best trend line. Okay, so both of these split the data evenly. That wasn't the debate. The debate is student 3, it doesn't follow the trend, which is the kind of point of it. And this one does do that. So we'll say student 4's trend line is better because it follows the pattern or the trend better, however you want to say that. Okay, I'm trying to avoid using the word in the definition or explanation because that's always fun. But basically, it's following the overall pattern of data a lot better than this is. Okay, so what we're going to be doing tomorrow is using our calculator to get what we call the equation. Sometimes we call it linear regression, line of best fit. There's all kinds of names for it. But basically, this equation here will be the actual equation for this line up here. So today you don't have to worry about how to get that. We're just interpreting it. Tomorrow you'll actually figure out how to get it yourself. But basically, what's the equation of that trend line? And then how do we interpret it? Okay, so what does the slope represent in this situation? All right, well, the slope is that number in front of x, the mx plus b, so 7.03. So that's the rate of something per something. And what we're comparing here is height and weight. So I gave you a sentence starter so we can just kind of fill in the blanks today. But for each inch increase in height, it means that the weight of the NBA player, and it's a positive 7.03, so we're going to say increases. If it was negative, we would say decreases. Increases about 7.03 pounds. I mean, you could round that to 7 if you wanted. But basically, for each inch in height, it seems like the player gains on average around 7 pounds for that inch. What does the y-intercept represent in this situation? That's the plus b. Include that minus sign because that's very important here. Okay? And it's the y-intercept, which if you remember, we write 0, comma, and then that b value that we get from the equation. So if our independent variable's height and our dependent variable's weight, that's basically how we kind of write this as a sentence. So for a height of 0 inches, the weight of the NBA player is approximately our b value, which is negative 332 pounds. Yeah, that's exactly what it's telling us. Doesn't make a lot of sense, but that's what the model is based on. So that's the thing with models. They have limitations to how realistic their predictions are, especially once we go outside of the data points we were given. And obviously no one had a height of 0 inches because that's not possible. So when you start making predictions of things that aren't going to probably exist in the first place, your predictions aren't going to make any sense, and that's okay. You have to use your brain at that point and go, even though the math is saying this, I know that doesn't make sense. So this is not realistic. It's just what our model is stating. Okay, so we're just interpreting here. Part C and D, we're using our equation up here at the top to make predictions based on more realistic heights. So not a height of 0, but let's say a height of 71 inches. How much do you think that that NBA player would weigh? So we're going to use our model y equals 7.03, and instead of x, we're going to actually plug in 71 inches. And then the rest of the equation says minus 332.45. And if you type that in your calculator, you can type it all at once, and you should get 166.68 pounds is the predicted weight of that player. Okay. We're going to do the same thing with 82 inches. All right. So this time we're going to plug in an 82. We're going to see how much heavier that person would be. All right. Here we go. Here we go. We're going to type that in. And I'm getting 244.01 pounds. So definitely a lot heavier. But they're not quite, but almost a foot taller. Right? A little bit less, but definitely significantly taller. So that's how you can use these linear regression models to make predictions that do make sense, even if, our y-intercept may not make any sense in the real world. All right, so for our last page of notes today, it's on temperature and ice cream sales. So it says the scatter plots below show the relationship between temperature and ice cream sales. The same scatter plot is shown below with 4 different trend lines. So we're trying to figure out which of these would be the best trend line. So pause the video here and just think to yourself what you would answer first. All right, so hopefully we can at least decide D is out, because that's the one where it splits it in half, but it doesn't follow the trend at all. So they're easy to spot, easy to mark out. Okay, so then we're looking at A, B, and C, and now we're going to see which one split it evenly. So A has 1 above and way more than 1 below. That's definitely not even, so A is out. B has a ton above, just like way too many above. It doesn't even have any below, so that one's definitely out. So I think this means that C is going to be our best bet, because let's see, we have 1, 2, 3, 4, 5 above and 1, 2, 3 below. Not perfect, but definitely closer. So we're going to choose C. Because it splits the values evenly, or splits them in half, however you want to say that, and follows the pattern. All right, number 5. What does the slope of the trend line tell us about the relationship between the 2 variables? So we're comparing temperature in degrees Celsius and ice cream sales. So really what we're talking about is how these are affected by these. So we're going to say that whatever the slope is, we're not going to find it today, but whatever it is, it's definitely positive or increasing. And what we're talking about is ice cream sales. So it's how much our ice cream sales are increasing for each degree Celsius we add to the temperature. So that's basically what we're going to write for number 5. So how much ice cream sales increase as the temperature increases 1 degree Celsius. So we only look at 1 degree at a time. Does this relationship make sense in the real world context? Well, why would ice cream sales increase as temperatures increase? Well, yeah, that makes sense. More ice cream is probably bought or sold, however you want to think about. Consumed in the summer or warmer months of the year, right? Because when it's hot outside, we want something nice and cool. Obviously, even if that's a trend, we would know in our brains, like, there's a limit to that. It's not just going to keep increasing Obviously, our temperature doesn't even get but to so hot in degrees Celsius, and then it would have to come back down. But that's definitely a trend we would be able to observe. All right, this concludes your video lesson on scatter plots and trend lines.